तो हम लोग बात कर रहे थे डिले लाइन का। डिले लाइन क्या काम करता है। तो ये बोले कि वर्टिकल सिग्नल जो है हॉरिजॉन्टल सिग्नल से कंपेयर टू जल्दी पहुंच जाता है। So for this reason, the vertical signal at the output of vertical amplifier should be delayed with the help of delay line. So delay line is almost delay time is almost equal to 200 nanosecond. तो अभी ये समझ में आया कि जो डिले लाइन है ये बेसिकली क्या करता है। जो वर्टिकल कंपोनेंट है ये हॉरिजॉन्टल कंपोनेंट और वर्टिकल कंपोनेंट दोनों एक साथ पहुंचे यहाँ पे, इसलिए ये कुछ ऐसा सर्किट है जो इसको डिले कर देता है सिग्नल को। सो दैट इज द रोल ऑफ डिले लाइन। देन टाइम बेस्ड जनरेटर एंड ट्रिगर सर्किट, जो हम लोग ये देख रहे हैं, दीज आर टू थिंग्स रिमेनिंग। जो हम लोग बाकी सबका बात किए, वर्टिकल हॉरिजॉन्टल एम्पलीफायर, डिले लाइन, ट्रिगर सर्किट क्या है, टाइम बेस्ड जनरेटर क्या है, इनका बेसिकली हम लोग अभी ये समझ रहे हैं इनका रोल क्या है, क्या करते हैं जो यहाँ पे लगे। तो टाइम बेस्ड जनरेटर क्या करता है, इट इज यूज्ड टू रिप्रोड्यूस द वेवफॉर्म एक्यूरेटली। जो वेवफॉर्म सिग्नल का है उसको एक्यूरेटली रिप्रोड्यूस करने में हेल्प करता है। इट जनरेट रैंप वोल्टेज which is having constant horizontal velocity. Constant horizontal velocity which the function of deflection voltage and expressing time per division. तो क्या इसका मतलब है कि पहला चीज तो ये कि ये इसका काम ये है कि जो वेव फॉर्म है, हम लोग जो सिग्नल का वेव फॉर्म देख रहे हैं यहाँ पे, ये एक्यूरेटली दिखे, इसमें इसका काम है टाइम बेस्ड। तो ये करता क्या है कि एक रैंप वोल्टेज जनरेट करता है जो कांस्टेंट हॉरिजॉन्टल वेलोसिटी देता है। जैसे कि मान लो कोई सिग्नल है जो साइनसॉइडल वेवफॉर्म में है ऐसे करके, और अगर हम उसमें हॉरिजॉन्टल कंपोनेंट ना दें तो स्क्रीन पे क्या दिखेगा, एक स्पॉट जो एक लाइन जैसे बनाएगा, जस्ट एक लाइन दिखेगा। अगर हॉरिजॉन्टल कंपोनेंट में उसका एक प्रॉपर एक कुछ रैंप वोल्टेज देके एक कांस्टेंट हॉरिजॉन्टल वेलोसिटी जनरेट हो जाता है। तो जो ये सिग्नल साइनसॉइडल वेव है वो हम लोग को ऐसे ऐसे मूव करते जैसे दिखता है। तो वो काम टाइम बेस्ड जनरेटर करता है। जैसे स्क्रीन पे हम लोग देखेंगे तो सिग्नल ऐसे 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 करके जैसा लग रहा है कि मूव जैसे हो रहा है। तो मूव इसलिए होता रहे, अगर वो हॉरिजॉन्टल कांस्टेंट हॉरिजॉन्टल वेलोसिटी नहीं देगा यहाँ पे, तो जो साइनसॉइडल वेव है वो जस्ट हमको एक वर्टिकल लाइन जैसे दिखेगी, और जो ये स्पॉट है दिस विल जस्ट गो अप एंड डाउन। So we will be having an line on screen, and actually sinusoidal wave है तो sinusoidal wave की तरह दिखना चाहिए। So that is why we need this time-based generator. So what it does, it's used to reproduce waveform accurately और एक horizontal constant velocity देता है जिससे कि हम उस सिग्नल को देख पाए प्रॉपरली। ट्रिगर सर्किट जो है वो क्या करता है, इट इज एम्प्लॉयड टू सिंक्रोनाइज द हॉरिजॉन्टल डिफ्लेक्शन विद द वर्टिकल इनपुट एंड इट लिंक्स द वर्टिकल इनपुट एंड हॉरिजॉन्टल टाइम। तो अगर अब हम लोग देखें फिर से वो ब्लॉक डायग्राम जो हम लोगों ने बहुत कल शुरू में देखा था, नाउ वी नो मोर अबाउट दिस डायग्राम। नाउ वी नो इन कि जो अलग अलग ब्लॉक्स है, अब इस ब्लॉक में क्या है, ट्रिगर सर्किट क्या सर्किट है, वी हैवंट डिस्कस्ड इट, बट वी नो व्हाट डज इट डू। टाइम बेस्ड जनरेटर जो ये ब्लॉक है, ये इसमें क्या सर्किट है हम लोगों ने डिस्कस नहीं किया, बट हम लोग ये जानते हैं कि इसकी जरूरत क्या है, ये क्या काम करता है सीआरओ। सो वी डिस्कस ऑल दिस यस्टरडे। We told about the power supply that CRT needs high voltage supply. So we have two types of supply in CRO. One is for CRT and another is low voltage required for the feature control gate focusing on another circuit of CRO. So for that was there. So now we are starting to discuss a part of like how it operates and what are the sensitive parameters we need to look into to find out how efficient, how sensitive our cathode ray oscilloscope is. So one thing is the deflection sensitivity of cathode ray tube. It is a parameter which tells that the CRO which we are using, how sensitive it is. So first we will define what is deflection sensitivity, and then we will do some numerical examples to better understand the concept. So as you remember from experiment when you have seen the CRO and whatever we have discussed with the block diagram, on the screen we see visualization of signals. Whatever signal we give, we see it on the screen. So the spot of electron gun, it may give you don't give any signal on the screen, you will be seeing a spot. The spot is because of electron beam is hitting on the screen at that point. So when we give signal, it changes, and because of horizontal and vertical deflection plates, it moves through the screen. So deflection sensitivity is defined as the shift of the spot of light on the screen per unit change in voltage across deflection plates is known as deflection sensitivity of CRT. So how we define deflection sensitivity? जो स्पॉट है स्क्रीन पे, अगर हम डिफ्लेक्शन प्लेट पे 1 यूनिट वोल्टेज चेंज करें तो कितना वो स्क्रीन पे शिफ्ट करता है. This is the thing which defines its deflection sensitivity. So this is how. So for example, if a voltage of 100 voltage applied to the vertical plates produce a vertical shift of 3 mm in the spot, then deflection sensitivity will be the voltage applied and shift. So the shift 3 mm and voltage applied is 100 volt. So we divide 3 mm divided by 100 volt. That gives deflection sensitivity. So deflection sensitivity becomes for that CRC is 0.03 mm per volt. So this is how we define deflection sensitivity for any CRT. This is the formula you will need. Sometimes deflection sensitivity is given, and it asks that if that much voltage applied, how much spot bed shift. Or sometimes voltage is given, deflection is given, deflection sensitivity is asked. So you can calculate anything with this formula. So this is the formula to calculate deflection sensitivity. Deflection sensitivity is defined as spot deflection by applied voltage. So deflection sensitivity not only depends upon the design of tube, but also on the voltage applied in accelerating anode. So one thing is there, like what we define that if we give some voltage, how much shift in the spot, that by that we can define deflection sensitivity. Then now we are talking about on what kind of parameters it depends. So as I told earlier, that design of tube, it is specific to particular CRO as well. What kind of tube it is, what is the size, and how it has been designed. All this decides the deflection sensitivity. So for every CRT, there will be a deflection sensitivity depending upon its design. And also, there is another thing that it depends also on the voltage applied to accelerating anode. Accelerating anode पे हमने कितना voltage apply किया है, that also affects deflection sensitivity. तो डिफ्लेक्शन सेंसिटिविटी इज लो एट हाई एक्सेलरेटिंग वोल्टेज। अगर एक्सेलरेटिंग वोल्टेज हमने ज्यादा लगाया है तो डिफ्लेक्शन सेंसिटिविटी कम कर देगा। सो दिस इज वन थिंग। सो डिफ्लेक्शन सेंसिटिविटी डिपेंड्स अपॉन टू थिंग, वन इज डिजाइन ऑफ द ट्यूब, अदर इज द एक्सेलरेटिंग एनोड पे कितना वोल्टेज लगा है। एक्सेलरेटिंग एनोड कहाँ होता था? It was in a electron gun. If you remember, I can go back to the slides and so where we used to have this. This is electron gun. This is accelerating anode. Accelerating anode, what it does, it attracts emitted electrons from this filament and it accelerates them to move in this direction. So यहाँ पे हम कितना वोल्टेज देते हैं, that also matters. That also decides when we talk about deflection sensitivity. Other than that, design of CRT is a factor which decides what will be the deflection sensitivity of cathode ray tube. So today we have defined this new parameter, that is deflection sensitivity. It kind of it says how sensitive our CRT is to the signal. So we defined, we gave it a definition. We said how on what factors it depends. This is one thing. So now I want to show you two numerical examples where we use this formula to calculate deflection sensitivity. Sometimes spot deflection is given, applied voltage is asked. This formula has three things: spot deflection, deflection sensitivity, applied voltage. If any two are given, third can be calculated. So we need to know this formula. So this is one example. There are two examples. I will be discussing both of them. I think these examples are very simple. Probably, if you remember, whenever I'm teaching something, I try to explain things with very simple examples. So the examples are not very difficult. You don't need to put a lot of work in that, but it just it gives a clarity what deflection sensitivity is and what kind of numerical problems we can do to better understand the concept. So in this example, you see the deflection sensitivity of CRT is given. It is 0.01 millimeter per volt. This is deflection sensitivity of CRT. And it is asking find the shift produced in a spot when 400 volts are applied to the vertical plate. So we know the formula and we just need to put it into there. So we know the formula, the spot shift is deflection sensitivity into applied voltage. So this is deflection sensitivity is 0.01 and applied voltage is 400. So this becomes 4 millimeter. So in this CRT, if 400 volts is applied on the vertical plate, the spot on the screen will shift 4 millimeter. So this is, I think it makes with more clarity what is deflection sensitivity and how we can use this formula. And then this is another question on the same formula. It says the deflection sensitivity of CRT is 0.07 millimeter per volt. If an unknown voltage is applied to the horizontal plates, the spot shift to 3 millimeter horizontally. Find the value of unknown voltage. So here again, we have deflection sensitivity. This time we are given spot shift. How much is spot shift when voltage is applied? So now we know the spot shift. This is the formula: spot shift, deflection sensitivity, and applied voltage. So applied voltage we can calculate by spot shift divided by deflection sensitivity. So we find out it is 100 volts. So this was the definition: deflection sensitivity, and then deflection sensitivity and what things it depends, and then what is the formula. And we try to do two simple examples to understand the concept of deflection sensitivity. And you see, this is in this example, it shows voltage is applied on the vertical plate. In this example, it shows the vertical applied voltage is applied on horizontal plate. So it means CRT is dependent upon the design of tube. So it is not a common for every CRT. It depends upon what is the design, what is the how it has been designed, how these are different nodes and all put in the tube. And then other thing, it depends upon the accelerating anode. The voltage we give an accelerating anode. But whenever it is not talking about the voltage given, so we can assume that in this particular condition, the voltage given to accelerating anode is a constant. It is not changing. So when it is not changing, deflection sensitivity for CRT remains same. If we change accelerating anode voltage, then it may change this deflection sensitivity of CRT. So for that situation, we can't use this number. So since the question doesn't talk about any change in accelerating node, so we can use this formula. So this formula you need to remember. You may have to solve this kind of simple numerical problems in a test or in exam. So from that point of view, which is important. Another thing is we understand what is deflection sensitivity. I think the concept of deflection sensitivity is clear. You understand what does we mean by deflection sensitivity of CRT.